In this video, we're going to provide an introduction to Python. It's a scripting language that I think is most like C in terms of its ability to be used as a general purpose programming language. And in this introduction, I'm just going to hit on some of the general principles of Python and some of its principal uses. So we're going to start by showing how Python can be used as a calculator, because that will allow us to look at its numeric types. And then we're going to see how it can be used for prototyping. For example, prototyping algorithms before you would actually implement them in a compiled language like C. And that will give us some insight into its other interesting thing, which is its high-level data structures like lists and hash tables, which we actually call dictionaries in Python. So let's get started and show you how Python can be used as a calculator. So at the command line prompt, you can type the word Python, and as you can see, I'm now in a command line interpreter. You can assign values to variables, so I'm going to say a equals 6, and if I now print a, it has the value 6. And if I want to sum a series of numbers, say 56 plus 25 plus 81, there we go. Of course, I could assign those numbers to a variable. If I want to do arithmetic on them, I can do division. So one handy thing is I forgot to assign them to a variable, but I can use the underscore as a reference to whatever the last result was. So for example, if I divide by 10 here, I get the result 16, which is 162 divided by 10. And you can see, as you might expect, the division operator does integer division on integer operations. So you can do any of the arithmetic operations that you could do in a normal language. So for example, 56 plus 10 times 50 divided by 3.15 gives you a nice number. One nice thing about Python is the exponentiation operator is built in. It's the double asterisk, so this is 2 to the third power 8. And that can be handy because you don't have to import a math library like you do in C or C++. So that gives you a quick introduction to just using Python as a calculator. Let's now show how it can be used to do some rapid prototyping. And for this, we're going to write a quicksort algorithm that isn't actually very efficient, but which would allow us to test a supposition, which is, let's say we have a supposition that we can, let's say we had a supposition that if we had a list of numbers, like say this, that if we divided it roughly in half based on the first number in the list, what we call the pivot, that we would have a pretty quick algorithm, and that when we were done it would be sorted. So here the pivot's 4, so we're going to put anything less than 4 on one side, anything equal to 4 in one list, and then anything that is greater than 4 into another list. And our claim is if we keep doing this recursively, it's going to be sorted. Now, you should be familiar with the quicksort algorithm. I'm going to actually write it in a little bit different fashion. So I'm going to take an argument, which is going to be a list. And before we do that, you probably need to see what a list looks like in Python. It's a built-in entity. And the way you create a list is with brackets and a comma-separated list of values. So for example, this is a list. And it's actually represented internally as an array. So while Python provides operations that make you think you're dealing with a linked list, in fact, you're dealing with an array. So only operations that actually insert at the end of the list are really efficient. However, if you remember from the introduction to scripting languages, we're not always concerned with efficiency. Often we are concerned more with being able to mock up an algorithm or to do something quick and dirty, and we don't care if it takes extra time to execute, which is going to be the case here with our quicksort algorithm. So we have a list, and this is, again, you can see it's built-in operator for it. The syntax is built in for creating a list. So let's create a quicksort algorithm, and we'll take a list L. And you can see the way we create a function is with def, and then at the end of it, instead of curly braces, you see we have a colon. And another thing that's kind of quirky about Python is that you use indentation rather than curly braces to show blocks. So here we're using an indentation of 2 spaces, which is kind of conventional in Python for the number of spaces you would indent. So what we're going to do is we're going to create 3 lists, and we're going to have what we call the lower list, which is going to be for anything less than the pivot, the equal pivot list for anything that's equal to the pivot, and the upper list for anything that is greater than the pivot. So we're now going to go through each element in the list, and the way we can do that is to iterate over each element in the list. So we'll say for element in L, and this is the way you iterate over a sequence in Python. So we'll be seeing many types of sequences as we go through Python. An array would be a sequence, a list would be a sequence. And this is going to return each element in the list. So we're going to compare that element with the pivot element. So if the element is less than L sub 0, then we are going to assign it to the lower list. Okay, now you're going to see something that may look a little odd, else if, and you notice I did not write it this way. So this is the way you would write it in a language like C or C++. This will cause a syntax error in Python. You actually have to write it without the E, and that was supposed to just to save a little bit of space, and I think also to make it look a little bit more like a switch statement. So now we're going to check to see if the element is equal to L sub 0. And if it is, then we are going to assign it to the equal pivot list. And finally, if neither of those conditions were true, then we know it must be strictly greater than the pivot element. So we'll add it to the beginning to the end of the upper list. And when we're done, we should have 3 lists, one containing all elements less than the pivot, one containing all elements equal to the pivot, and one containing all elements greater than the pivot. So now we should be able to return what would happen if we sort the lower list, and then we can use plus for appending 2 lists together. So this is very handy. So we don't have to quicksort the equal pivot list because those elements are all equal, and then we'll quicksort the upper list. So there's a couple cases that to be considered for the recursion. First of all, we could have an empty list coming in, so we have to check to see if the list is empty, and we can do that with the length operator. So if it's equal to 0, or if the length is equal to 1, then we're simply going to return L. So this is one way to write it, and you can see that instead of using the pipes like you do in C or C++, you actually write out OR. And this is not as perhaps easily understood as if we could just say if length of L is in 0 or 1. So this is actually a shorthand that you can use. It's just saying is length of L in that list, and even though it's not the most efficient, it's easy to read. Okay, so we're going to return L in this case. The other thing we probably should do is, nope, we don't have to do anything else, because if the other thing I was going to do is add the pivot to this equal pivot list, but in fact when we go through this for list, the first element will be the pivot, it will be equal to the pivot, and it will be added. So this is our quicksort algorithm, and we can actually test it. So I'm going to create a list. So list to sort equals, and we'll create some numbers. Let's give it a nice thing, so 3. So there's our list, and we're going to want to print it when we're done. So we will print quicksort and list to sort. And this is now going to show us the second way that we can. The second way I can run a file is just by typing Python and the name of a file, which in this case is play.py. In fact, you can see I got a syntax error. And the reason I got this syntax error is actually after making a big deal about else if, it's actually elif that I want it here. So it's actually elif rather than else if. Also, I note at this point I didn't need these parentheses. In fact, you often don't put them there in Python because the colon already serves as the delimiter that we want it to be. So we can try it again, and it prints out a nicely sorted list as we had hoped. Also, I could have done the same thing in the command line interpreter using the import command. That would import it, and it would define this quicksort function. So in fact, you can see I could create my own quicksort function, or not, but just sort a list such as that. Okay, that didn't work. But if I say play.quicksort 10, 5, 28, then I get the right result. So you can also import files as though they're modules, and we'll talk about that in a later lecture. Now that I have this quicksort algorithm and I know it works, I could actually go and do the in-place algorithm that sorts it in place. This algorithm is pretty inefficient because I'm actually creating new lists each time that I call quicksort. So rather than doing in-place sorting, I'm creating totally new lists, and this would be pretty inefficient. Nonetheless, this shows using Python as a prototyping mechanism. We also see a whole bunch of other Python elements that we'll just quickly review, starting with def, which allows us to create a function, and the colon, which is what you use to with most control structures like loops or if then else's, and it's a way of starting a new block rather than using curly braces. And then the indentation, you have to use the same indentation, so everything at the same indentation is part of the same block. Therefore, Python knew when this function ended down here, because the next statement, list to start, was back at the beginning lined up with the def, and therefore it knew that I had terminated the function. So some other things we saw was the use of control structures, so the for loop to iterate over the list, and we saw the use of if, elif, and else to as a conditional statement. We saw the use of len to return the length of a list, and this little idiom where instead of using or, we just created a list and checked whether the value was in that list. And then of course you see how we were able to manipulate lists. We first created lists, we were able to append to lists, and then we were able to use plus as a concatenation operator to concatenate 3 lists into a single list. So now we've seen basically 2 of the basic data types in Python. We've seen integers and numbers. We've seen lists, which are a fundamental data structure. Obviously, strings are another fundamental data structure, and there's three types of strings actually. One's with single quotes, like BCD. You can use double quotes, or you can use triple quotes. And the advantage of using triple quotes is that you can string a line across multiple, you can create a line and break it across multiple lines like I did right there. That's the typical use for triple quoted strings. Also, they're typically used for documentation strings. So if I went back here and into my function, you often at the top of the function are going to see a so-called documentation string that can be used by some of Python's automatic documentation tools to document it. So for example, you might see Quicksort, a quick sorting algorithm, and then you'd have an empty line and parameters, L, a list to be sorted. So another use of the triple quoted string is as a documentation string that can be used to document functions. As I said, Python has documentation tools that can extract these strings to create nice documentation like web pages that make it easy to see the API for a particular module in Python. Now whether you use singly quoted or doubly quoted strings doesn't make much difference to me. If you need to put a single quote in something like, say, Brad's dog, you would have to use double quotes. Similarly, if for some reason you want to have a double quote in something like Mary said he went home, then you'd need to use single quotes. For those of you who've used Perl and are used to string interpolation, you cannot easily do string interpolation in Python. You have to use something called its format statement, which we'll talk about in another lecture. There are some handy things that you can do with strings. First of all, you can access a string using it as an array. So I could say quote equals, now I could say quote 1 and get the first letter, or I could use a slice like 3, 8, and that gives me a slice starting at 3 and ending at 7 actually, so one less than the end of the range. I can also go from the back of the string, so I could say quote -4, and that gives me the O in home, or quote -5 to the end of the string, and that gives me home with the last double quote. So you can use minus signs to index from the back of a string. You can use the colon with a number on the left and the number on the right to extract a slice from a string. You can do string concatenation easily, so I could say name equals Brad plus space plus van der Zanden, and that will give me a string that has been concatenated as Brad van der Zanden. Also, you can get the length of a string using the length function. Finally, strings are immutable, so if I tried to say name1 equals A, name1 equals A, then I'm going to get an error. So you can't change a string. If you do assignment, like if I were to say new name equals name, I'm actually getting a pointer to name, and I'm actually not modifying it. Now, the same operations that apply to strings apply to lists as well. So if I have a list, say L equals Brad, Smiley, Yvonne, Mary, Nancy, then I can take a slice out of that, or I can start indexing from the rear to get elements from the rear. And you already saw that I can append to a list using the plus operator. Unlike strings, lists are mutable. So I could, for example, say L of 3 equals Joe. And now if I printed out the list, you can see that Joe has replaced Mary. I can also replace parts of lists. Let's say I wanted to delete the first and second elements of the list. I could just say first and second elements equal that. And now if I do list, you can see that I deleted actually just Smiley because it went from 1 and did not include 2. Let's say that I wanted to delete elements 0 and 1. I could say elements 0 through 2 is the empty list. And now I just have Joe and Nancy. One thing you do have to be careful about is when you pass a list to a function, the list is mutable because you're actually passing a pointer. So Python is using pass by reference. So for example, if I have def modifier and it takes a list, and let's say I say L of 0 equals Brad, and now I call it with my list L, you'll see that when it's done, we have Brad Nancy. However, if instead I were to call it with modifier L1 colon, so now I'm passing it the list consisting of Mary, you'll see that when it comes out, L has not been modified. I'm sorry, it was Nancy, not Mary. But it was not modified because when you pass a slice of a list to a function, then it creates a copy of that slice. So that's a small subtle thing that can trip you up in Python if you're not careful. Now another type that you have in Python are just bools, so true and false. And there's some interesting things that you can do with Boolean operators. So first of all, you can apply relational operators to both strings and to numbers. So I can, for example, say, is Brad less than Nancy? The answer is true. Remember that when you do a Boolean operator, it's going to use or, and, or not as your Boolean operators. Now when I said you can do some interesting things, what I was referring to is you can do chaining. So let's say we say A equals 15. You may remember we used to make a big deal in 102 about how you have to, if you want to know if A is between 10 and 15, you have to write is A greater than or equal to 10 and A less than or equal to 20. The answer is true. Well, in Python, you can actually just write 10 less than equal A less than equal 20, and you also get true. So what we did here was we chained it. We first had 10 less than or equal to A, and then it also asked is A less than or equal 20. It was like asking is 10 less than or equal to A and is A less than or equal to 20. Here's another one. We might say B is equal to 30, C is equal to 40. We might ask is A less than B equals C? And the answer is false because while A is less than B, B is not equal to C. So that's a handy thing that you can do with Boolean operators. Now if you want to print something in Python, you use the print statement. So let's say that we wanted to create a program that was going to print prime numbers. No, I'm sorry, not prime numbers. You're going to print Fibonacci numbers. You want to print Fibonacci numbers up to a certain number. So I'm going to define a thing called fib_n. So I wanted to create all the Fibonacci numbers up to n. So again, I'm going to use something that demonstrates some of the features of Python. So here I'm doing multiple initialization. And while my Fibonacci numbers, I haven't generated n of them, I'm going to print the Fibonacci number. And I am going to update them. And again, you see some interesting things right here. So first of all, I have a while loop. So the while loop is a lot like it is in C or C++, except we have a colon after it. The print statement is what we use to print things. And here we have Acute multiple assignment where we are assigning fib2 to fib1, and we're assigning fib1 plus fib2 to fib2. And these all values on the right-hand side are calculated before I do any calculations on the left-hand side. And this is really nice for swapping two variables. So let's say I have B, you can see up here is equals 30 and C is 40. Now I can simply say BC equals CB. We print out B, you can see it's now 40, and print out C, it's now 30. So this is a handy construct in Python that allows you to evaluate everything on the right-hand side of an expression and then assign the result to the values on the left-hand side. So let's see what happens if we have fib of 10. So let's store this. So let's go over here and try running it. And you can see it didn't quite do what I had promised because it generated 6 Fibonacci numbers rather than 10, and I'm thinking, what happened? Well, in fact, I was going up until my Fibonacci number was greater than 10. So in fact, this will show you another feature. So what I really want to do is say for I in range, we'll start with 1, 10. And it's not going to exactly create what we expect, but it will be a start. So what we're doing, in fact, we don't want range 1 to 10, range 1 to n. And what that's going to do, the range is going to create a list with the numbers 1 to n minus 1. So if we go over here and just look at, say, range 1 of 10, you see it generates the numbers from 1 to 9. So it's always 1 less than 10. And this is how you actually have to write a counting loop in Python. There's no for I equals 0, I less than n, I plus plus, as there is in C or C++. And Python uses, this may seem inefficient, and it may be slightly inefficient, but Python doesn't generate the entire list at once. It uses what's called a generator function to generate the elements of the list one at a time. So we could instead do this. So we're printing what seems to be n Fibonacci numbers. So going over here, we again run it. And we get 1, 2, 3, 4, 5, 6, 7, 8, 9. So in fact, we do get what we wanted, which is 10 Fibonacci numbers. Now, we could also come over here and we could print more. So let's say we wanted to print both what the number, the Fibonacci number was. So let's say Fibonacci number and then I and then equals fib2. And if we run it, you can see we get Fibonacci number 1 equals 1, Fibonacci number 2 equals 1, Fibonacci 3 equals 2. And you actually see there's 2 spaces between number and the word number and the actual number. And that's because I did not need to put this space here. The print statement automatically puts a space between each set of values that it prints out. So if we went back here and now ran it, you see we get the formatting we want. So this suffices for simple formatting in Python. If we were going to do more sophisticated printing, that's going to be shown in another lecture. Now, as I was saying, there's no formal equivalent of a counting loop in Python. So you have to use the range function if you want to do counting. So for example, if I wanted to sum the first 10 numbers, I would have to say for I equals in range 1, 11, because I want to sum the first 10 numbers, and then I could write sum equals sum plus I, and this would sum the first 10 numbers. Again, iterating over sequences is a big deal in Python, and so Python provides all kinds of handy shortcuts that allow you to iterate over different kinds of sequences. So you already have seen how we iterate over a list, but this only gives us the element in the list. What if we also wanted the index in the list? The way we can do that is with the enumerate command. So if we said for index value in enumerate, and let's say our values were tick, tock, tick tack, and toe. And let's print them out. Then let's copy and paste this over into Python and run it. You see we get the index values for tick, tack, and toe plus their values. So enumerate allows us to get both the index and the value. Now sometimes we want to be able to iterate through two lists simultaneously. For example, let's say that we had two vectors and we want it to take their dot product. So let's have these two vectors. And let's say we want to take their dot product, which if you remember is a pairwise multiplication of each of the values, and then you sum them up. So this would be the dot product of the two vectors. So the way we can do that is with something called the zip function. So if we say we zip, kind of like a zipper, so we're zipping the two sequences together. So get product equals product plus v1 times v2. Obviously we have to set the product to be 0 initially. And if we were to now run this whole thing over here and print product, we have 2750, which is the value that you get. So using zip allows us to do a pairwise operation on two or more sequences. You could have a third or fourth or fifth sequence in there as well. The one requirement is that the sequences all have the same length. If you want to go through something in reverse, you would say reverse. So I could say for v1 in reversed vector 1, print v1. And if we take that over here, you're going to see here's vector 1, 10, 20, 30, 40, 50. We do it over here, we print it out in reverse order. So reversed is an efficient way to reverse the elements. And we have also a way to iterate through dictionaries, which we have not presented in this lecture, but we'll get to in a subsequent lecture. Now, for loops and while loops also have the break and continue statements, which work just the way you would expect, but they also have a very neat statement, which is an else at the end of it. So you can put the else at the end of the statement, and to illustrate it, we're going to write a fragment of code that's going to determine whether a number is prime or not. So if it's prime, it should print out that it's a prime number. If it's not prime, it should print out some factors. So let's do it in the range 2 to 10. And what we're going to do to determine if a number is prime is we're going to divide the number by any number between 2 up to n. Now I know we could do really n divided by 2, but for simplicity we'll just do up to 2 to the n. And if the x evenly divides it, then we know it's not prime. And in fact we have the factors. So we'll say n equals x times whatever n divided by x is. And we know that's evenly dividing it. And we also break out of the loop because there's no reason to continue. This is where the else comes in, though. So if we reach the end of the loop, in a traditional language, we wouldn't know whether we had broken out of the loop or whether we'd reached the end of the loop because we had exceeded a subscript. So we might have to say something like if x equals n, and now we know it's prime. But that's a little kludgy, and Python provides a nice operator else, which executes only if the for loop terminates. If a break statement is executed, then the else clause is not evaluated. So we know if the for loop terminates, the number must be prime. So here's a comment. So the loop fell through without finding a factor, so we know it's prime, and we print n is a prime number. Again, this hash represents a comment, so if it either starts a line or it is, say, over here, let's say we said n is not prime, so anything after the hash is also a comment, even if it's on the line with an executable piece of code. So if we come over here and we execute this, we find, as we expect, 2 and 3, 5, 7, and 9, 5 and 7 are prime numbers. The other ones have factors for them. The final thing we're going to talk about is functions. And we've already seen them. But just a few facts. First of all, primitive types are passed by value. And objects are passed by reference. Making them mutable. So if you change an object in a function, then its value will be modified when it comes out of that function. So the next thing about functions is that variables are local by default in a function. So if I say def A, I say B equals 10, B is local to A, and scope will go out of scope when A exits. Now if I were to say B equals 10 plus C, C is undefined, but if I define C globally, then it would go outside the function looking for a value for C. However, if I were to say something in here like C equals 50, then it would create a local version for C called 50, and B with a value of 10, no, B with a value of 60 because it's 50 plus 10. The global C would still be equal to 20. Now you might ask what happens if instead of saying C equals 50 here, I said C equals 50 here. What value do I get here for C? And the answer is you'll get an error from Python when you try to compile it. In fact, over here I did so. I set C equal 20, defined A, set B equals 10 plus C, set C equals 50, printed B and C, and when I executed A, I got an unbound local error, local variable C reference before assignment. So in fact, Python does look ahead and sees that C should be a local variable, gives me an error message. So in fact, what I wrote here would not be allowed. Now you might say, what happens if I really did want to modify that global C for some reason? Then what I could do is I could declare C as a global. And now if I said C equals 40, in fact this value of C would change to 40 because I declared C as a global. So this concludes our introduction to Python. We've seen that Python can be used as a calculator and that it also can be used for general purpose prototyping, and that it has a built-in type called lists, which make it very easy to manipulate lists.